Hello everyone, I'm Anand from Axway Global Customer Services based in Sydney, Australia. I'll be giving you a demonstration of autoscaling of Axway API Management Platform. The objective of demonstration is to provide you tips and guidelines for building an API management platform which is highly available, fault tolerant, strictly adheres to SLA, and is cost efficient. The demonstration will be provided using AWS, hence it's important that you are familiar with AWS components, as well as have also a basic understanding of Axway API management platform and different components like admin node manager, API gateway, API manager, and Cassandra. The demonstration is a multi-part video series, and I would suggest you to watch the series in sequence. Thank you. So in the presentation, we'll cover following topics. Topic number one would be API management and elasticity. In this topic, we'll talk about the features of Axway API management platform, which makes it very easy to configure autoscaling. Then we'll talk about architecture, setup, and tools. In this topic, we'll talk about architecture, which is very friendly for autoscaling and simplifies the autoscaling part. Then we'll do a demonstration in which we will configure API management platform and then do some API calls and stress out the system and see that if the system can scale by itself. Followed by demo, we will do a deep dive into the components of demo. So in deep dive, we will understand the different scripts and how the demo was structured and how it scaled itself. So we'll look at all the intricacies of scripts and the details. And the last section would be about summary, in which we will talk about things to look out for, and the key takeaways, and how to progress from here, and where to look out for further information. So in this slide, we'll talk about different enablers which make the API management platform highly elastic and which let us to configure it to be auto-scalable. So number one is modular architecture. Modular architecture by itself means architecture made up of loosely coupled systems. In the same way, API gateway architecture can be called as a modular architecture because the platform itself is composed of different components which can be connected to each other. And the components does not need to be co-hosted on the same server, so they can be hosted on different servers which can be in different tiers or different zones. So this helps the gateway to the components of the gateway to scale independent of each other. So that's a very important feature which is required for making the platform highly elastic. Number two is highly available, which means that the API gateway platform can be deployed across different availability zones in AWS or different region, or it can even be hybrid. Third one is cloud friendly, which, as the name says, it can be easily deployed in cloud, be it AWS or Azure, or maybe if you want to Dockerize it, then it can be also deployed as containers. API driven, which basically means that API gateway itself being an API platform is also very puristic, and the internal also works via API. So which means we can configure the system by making API calls. You can do management operation by making API calls. You can get monitoring information by API calls. So that actually helps you to integrate with different scripts to detect or to perform different operations using API, which is very handy. And the last one is about installation. So API gateway can be silently installed, which means it can be installed without any manual intervention, which is very important in auto scaling. In this section, we will talk about the scalable architecture for the API management platform, and this relies on on one of the topics we discussed before, which was around modular architecture and how API gateway, or I should say API management component, is made up of different components in a modular way, and how they are disconnected from each other. So we're gonna leverage that concept and design an architecture which is highly modular, which enables each of the individual system to auto scale independent of each other. So in this slide, we're going to talk about an architecture which we're going to use for the demonstration. Now, this architecture is very modular because we have hosted the different components of API management on different servers and in different subnets, and they can scale independently of each other. So as you can see, I've got a VPC which can be spread across multiple availability zone. It's totally up to you. And then I have got three different subnets. So I've got a API gateway subnet, I've got admin node manager subnet, and I've got a Cassandra KPS subnet. Now, just a brief talk about the role of Cassandra. So Cassandra is used as a key property store in API management, and Cassandra is a NoSQL database. By design, when we add a Cassandra node, it basically results in a lot of data redistribution between the Cassandra. What it means that basically when you auto scale Cassandra, and usually you auto scale because the system is under stress, and if you auto scale a Cassandra cluster which is in stress, you're gonna increase the stress on the cluster. So ideally for Cassandra, you always forecast the number of servers you need, and you go with that maximum size, and you monitor it. And if you think that you need more servers, then you add more servers, but you don't do it during the peak time. So because of that reason, we will not auto scale Cassandra. We will go with a fixed size Cassandra cluster. Like in this case, we will have 3 node Cassandra cluster. So we'll not auto scale Cassandra at all. But the other two, which is admin node manager cluster and the API gateway cluster, are auto scalable cluster, and you see that the sign, the 4 arrows, those are the sign of auto scaling as per AWS sign convention. So let's talk about the admin node manager high availability subnet. So in this case, I've got 3 admin node managers. But doesn't need to be 3, it can be 2 or it can be 1. I advise to have at least 2 so that we can get high availability of admin node managers. So let's say, what if I don't have a highly available admin node managers? So what that would necessarily mean that I will not be able to do management operations on my API gateway. So admin node managers are not a very critical component. They don't process your API calls, but they do the monitoring of the API gateway, and they are the administration console. So it's always good to have HA of admin node managers. So so basically what we want from the admin node manager is not a scalable cluster, but a fault tolerance cluster, which means that if I've got 2 admin node manager and one of the admin node manager crashes, then the cluster should be able to restore itself, which means it should be able to bring back the second admin node manager, or it should be able to rebuild the second admin node manager. And we're going to demonstrate that in the demo. So similarly, we have got a API gateway cluster, which is a highly available auto scale cluster, and it can scale based on different metrics. The metrics we're going to use for this demonstration is CPU utilization. So whenever the average CPU on utilization on the nodes go beyond a certain threshold, the auto scaling cluster is going to add one more gateway to it. And whenever the CPU utilization drops to a certain point, then it's gonna bring back the cluster to a minimum size. And for the demo, we're gonna go with a minimum size of 2 API gateway nodes, or maybe 1 API gateway, and then we're gonna do some traffic or send some API traffic on it, put the system under load, under stress, to make the CPU utilization go up, and we will let the scaling go up to all the way to 3 clusters. And for doing this demo, we're going to use out of the box, or I would say AWS features like auto scaling group and launch configuration, and we'll not be using any proprietary tools. So let's quickly talk about the AWS components we're going to use for this demo. The first one is AWS AMIs. So what we're going to do is we're going to create few AMIs. AMI stand for Amazon Machine Image. So we're going to use AMIs which will be pre-baked with certain scripts and with the software which will be installed but not configured. And we're going to use those AMIs for creating the server. Similarly, we'll be using Amazon S3 where we'll be storing the scripts, and the AMIs will on instantiation they will gonna pull those scripts from Amazon S3, and we're gonna use features like Amazon CloudWatch and Amazon SNS for monitoring the EC2 instances and then generating alerts which will eventually trigger auto scaling activities. Let's talk about different security groups. So we will have a security group for each subnet. So basically the API gateway subnet will allow traffic on port 443 from the Elastic Load Balancer, which will be facing to internet, and the Elastic Load Balancer itself will be accepting traffic on port 443 from internet. Similarly, for admin node manager subnet, we have another Elastic Load Balancer which will be configured to accept traffic on port 8090 from API gateway subnet, and in the same way, admin node manager subnet will be allowed to to send traffic on port 8090 between the EC2 instances within that subnet, as well as to accept traffic on port 8090 from the admin node manager Elastic Load Balancer. API gateway subnet will also be allowed to accept traffic on port 8090 from admin node manager subnet, and similarly the Cassandra subnet would be allowed to send traffic on 7001 between EC2 instances in that subnet, as well as accept traffic on port 9042 from API gateway subnets. So this should not be complex. If you are familiar with the API gateway architecture or the components, you would know that what these ports are and how they are used for. So in the next part, we will talk about auto scaling, and actually we will do a demonstration of auto scaling, which is another video not attached to this one. So hopefully you will be able to find the next video to see the demonstration.